All right, good day, dear participants. I will call you participant because these are students that are spread across the globe that are really enjoying the statistic class. Of course, for almost 4 videos now, we have been looking at uh, all these statistical tools that we can actually use to uh, test some hypotheses. But unfortunately, we haven't been able to discuss what hypothesis is all about. But this time around, of course, we have looked into different statistical tools. We have looked into central tendency, which can be used to like a mean median mode to represent an information. From there, we move on to measure of dispersion, where we look at the variance, and then we look at the variance. We also look at the variance. We look at the standard. We look at the standard deviation. So all the way from there, we move away. We also look at other statistical tools as well, where we look at the test of correlation. So we look into the past videos. We have looked into the Pearson and then Spearman rank as well. So this time around, we want to look at the test of difference. Of course, before we talk about test of difference, we quickly want to look at testing a statistical hypothesis, because all these tools, all these statistical tools, before you can actually use them, you need to set what we call hypothesis, because you really want to find something out of it. So basically, when we look at hypothesis, is an assumption sometimes, or we may say it's a statement which may or may not be true concerning one or more population. So when we look at it now, hypothesis is a kind of a conjure preposition, is a form of an informed, intelligent guess about a solution to a particular problem. So that means there is a problem at hand, and you need to come up with an hypothesis to test whether the problem is real or not. So it's also, we can also see it as an assumption or a preposition whose validity is to establish. You want to establish something out of it. So therefore, there is need for you to formulate and thereafter you test that kind of hypothesis. So there are two, there are four sources of hypothesis. When you want to set them, there are four sources of hypothesis. One of it is that you can set an hypothesis based on your experience. These are the previous knowledge of a researcher about a particular problem you are talking about. Then you can also do it based on theory, that is through the process of deductive reasoning or hypothesis that could be derived from a theory. For example, if A is true, then B should also be true. Like the way we are looking at it now, let's say you have been looking at it, somebody gave a birth to a child, and say, this is a male child, or possibly the second one may likely to be female. So all this, we are still postulating a kind of what? A kind of a theory. So when we look at it, the third area of source of hypothesis could be in form of literature. When hypothesis, you may derive it from the, when you are reviewing a literature, you can also get it from there. Then, of course, from previous findings, that's the fourth one. So this gives a rise to some new issues which have to be resolved. Then the bias, you can later now formulate a kind of hypothesis for that based on your previous findings. Of course, there are different functions of hypothesis. One of the, I'm going to tell you just about three so that we can go into the test of difference. The first one is that it provides a guide or a direction to an investigation. It's going to give you a kind of a guide or a direction to an investigation. Two, it can also help you as a researcher to determine whether facts collected, enable you to decide how many facts are required to test adequately. And the third one is provide you as a researcher with an efficient instruction for exploring or explaining the unknown. And there are different qualities of a good hypothesis when you do them based on some of the source like that. One of the quality of a good hypothesis is that it must be textable. That means it should be such that it has a kind of empirical evidence relating to its validity, or based on related to what you have obtained. The second one is that in terms of a statement of expected relationship between two or more variables. So let's say, for instance, in a working with hypothesis, a good hypothesis should therefore specify the expected relationship between the two variables. Of course, when you look at some of the past videos we've talked about, I've talked about a variable, what a variable is all about. So a good hypothesis should therefore specify the expected relationship between variables of interest in measured terms. The third one is the consistencies in the current knowledge. Hypothesis should not contradict established knowledge. It must not contradict an established knowledge. If it does, it shows it is not is unreasonable. And the fourth one is unambiguous. Unambiguous, and hypothesis should be stated in a clear form. And the fifth one is plausible. A good hypothesis should based on what is consistent with reason. It should be seen not only related to a problem, but also likelihood as a solution to the problem that you have already discovered in the past. So, of course, basically, there are two different types of hypotheses. There is what we call a null hypothesis, and then, of course, what we refer to as an alternative hypothesis. So, what is a null hypothesis? A null hypothesis is the one that you postulate, or let me say, is the one that you formulate with the hope of rejecting. That, okay, if the one you formulate is not working, you are going to reject that one, then you go in for the what? For the alternative. And that is why we have the so-called the non-hypothesis. Once it is being rejected, you take the alternative hypothesis. So a non-hypothesis is the hypothesis of primary interest. That's exactly the primary interest, the major things you have in mind. So this hypothesis is usually put in a negative language. That's why they normally put it, you normally see there is no significance. That's a non-hypothesis. Once you see an hypothesis in a negative form, it shows you are really talking about the null hypothesis. So, for example, in a measuring, let's assume someone wants to measure the height of a female student. A height of a female student now between Nigerians and Ghana. So the non-hypothesis will be that the height of the adult female in these countries are not the same. So that means you can say there is no significant difference, or they are not the same. So the alternative hypothesis, on the other hand, this will definitely lead to the acceptance of another hypothesis that we call what is it called? Because once you reject the non-hypothesis, of course, you definitely go for the alternative one, and that is why we have the non-hypothesis and the what, and the alternative what hypothesis. So sometimes it's usually represented, the non-hypothesis usually represents with H0, while the alternative will be what? Will be H1. So let's go into the test of difference. Like I said, the first one that I have before me, we'll look into what we normally call a chi-square. A chi-square is often desirable to investigate if you are like if there's any discrepancy between the expected, that is the theoreticals, and the observer frequency of a given event. For example, when you throw a coin, you should be expecting that it comes either with what? With head or a tail. That's for a coin. It has only two faces, either the head or the what, or a tail. When you go into a gender, for instance, it can only be male or what, or female. So if a fair coin is thrown 10 times, for instance, we may be expected that the head will come out 5 times and the tail will also come out in 5 times. So if it is actually observed in a different way, it could be 7 heads and, of course, 3 tails. So these discrepancies may suggest that the coins is not fair. That is, it is somehow biased when you put it in that way. So that means the assumptions of the fairness is what? Is wrong. So the chi-square is the one we use to study the data reported in terms of what? The frequency, or forms that can be reduced to a frequency, such as a percentage, proportion, and what? And probability. Let's see the example that we have on the board with us. It's talking about a sales promoter that is advertising for brand of a powder soap. And you look at it now, it is the powder soap is labeled from A to what? A to D. So, which found among 80 prospective buyer. 80 prospective buyer is on stand, but the 30 of them opted for the first brand, the brand A, which is 30. The 10 of them, you know, they opted for brand B. The 25 of them opted for brand C. Why 15 of the 15s of this promoter, they opted for that of brand D. So we want to test this hypothesis that the four brands are not equally attractive to the buyer at all. So we have to bring in the test of difference into this. The tools we want to use to test this is what I call chi-square. So when we want to look at this now, we need to get the expected value. We need to first of all get the expected value. So let's go into this and see how we look at this. Of course, don't forget that we talk about the expected value as 20 of these. So we look into this, then we use this formula. So we are working towards the chi-square formula, which is summation O minus E. The O there stand for observe, while the E there is standing for the expected value. So sometimes it is easier when you put this one into a table. Let me say the market, let's say A to D, and we have it like this. This is the observed value for this, that is 30, 10, 25, 10, 25, and 15. And when we total this, everything together is 80. So the expected value, just like the case of the coin that I used the other time, the expected value will be 20 out of this, 20 out of this, 20 out of this, 20 out of this. And when we add that one to, it's going to give you 80. So here now, you need to find the difference between the observed value and the what? And the expected value. So when you find the difference between these two, the difference between these two will be 10. Difference between these will be what? Will be minus 10. The difference between these will be 5. Difference between these will be minus 5. So that is the difference between the observed value and the expected value. So thereafter, you have to square the observed minus what? Minus expected value. So when I square this, that will give me 100. When I square this, when I square 10, that will give me 100. When I square 5, that will give me 25. If I square minus this, it will give me 25 as well. And when I add everything together, this is going to give me 250. So let me put the 2's into the formula now. So if I put the 2 into the formula, my calculated value now, after calculating this, is the formula is summation observed minus expected all square, everything divided by what? Expected. So when I added this, it's giving me 250 divided by expected value, which is what? Which is 20. So let me get my calculator and divide this. So let me get the calculator and divide this. If you divide it from your end, what is it giving you? Can you divide it from your hand? And let's see what this will be giving you. So do that from your end. Okay. So I want to see that in the comment section. Can we have that? Okay, great. Someone is trying to put something on the other group. So that will give us, when you add the two together and you divide it, that will give us 12.5. So that will give us 12.5. So this now is the this 12.5, that is the value you calculated on that. So the next thing is that you need to get your 4-figure table because you want to take a decision now. At the point of taking decision, there are rules you have to follow. At the point of taking decision, there are rules you have to follow. And of course, you remember the rules is not far from the decision rules. And what did the decision rule says? The decision rule says that you reject the non-hypothesis if the calculated values of the tested is greater than the critical value. Of course, you have already got your calculated value as 12.5. So let's check from the table value. So that means you are using your 4-figure table. You go under, and you take your 4-figure table and you go under your chi-square table. Under your chi-square table, so checking it under 0.05 for your critical value. Let's check it from under 0.05. So if I check it under 0.05, that is going to give me 7.81. If I check it under 0.01 under the chi-square, of course, don't forget you need to get your degree of freedom. You need to get your degree of freedom. So how many are we observing? That is just 1, 2, 3, 4. So your degree of freedom at this point, it will be n minus what? N minus 1. So the observed value, which is 4 minus 3, that will give us minus 1. That will give me what? 3. So that means I'm checking this under that 3. So if I check it, like I said, which I put under that place, for the chi-square under 0.05 will give me 7.81473. So I'm picking 7.81. So for 0.01, if I check for 0.01, that will give me 11.34. So when we look at this now, you see that compare these two together. When you compare these two together, you see that the calculated value, which is 12.5, is greater than the critical value, which we normally call the table value. Is greater than this. So once this is greater than this now, so what is our conclusion? What's our conclusion on this? What is our conclusion on this? So our conclusion on this is going to be that, so once we have once the calculated value is greater than any of these critical value, because when you look at it at 0.05, 0.05 is 7.81. That means the calculated value is greater than that. For the 0.012 is also greater. So since this is greater than, so we are going to reject the non-hypothesis, and we go for the alternative hypothesis. So that means some of these brands are more attractive than other. Of course, what we set at initial stage is that there is no difference between the two of them. So, but since that we see that the calculated value is greater now, we are going to reject the non-hypothesis and accept the alternative hypothesis, which says that some of the brands are more attractive than each other. So that means there is significant difference. So this is how far we can go on the first test of difference, which is talking about the chi-square. So after this now, we move into the second one, which will be talking about the t-test. Then thereafter, we'll move on to the analysis of variance. So make sure you share this video with others that are not with us now. Thank you.